A quadratic function from standard form to vertex form, examples 3 and 4. Alright, so first things first, we move our constant term to the other side. So I'm going to put y plus 3 and leave a blank. And then on the other side, we have 2x squared plus 8x. And then we're going to put a blank. Now notice we have 2 in our problem where we have not had a number in front of x squared before. We need to take out that 2 before we complete our square. So take out the 2 and we have x squared plus 4x plus blank. And then we're going to complete the square. So we still take half of b, so half of 4 would be 2, and then 2 squared will be 4. But notice, on this side, we have 2 times 4 is actually the quantity we're adding. So on the other side of our equation, we can't ignore that 2. It mattered. It was part of our problem. So we have 2 times 4 that we really need to add on that other side. So you got to be careful when you have a number out front. It makes a little bit of a difference in what you do. So 2, and now we're going to rewrite our trinomial. Remember, it's a perfect square trinomial now that you've added in that 4, so we could rewrite it as x plus half of b, which is 2. And then bring down what's on the other side and just clean it up. So we now have y plus 3 plus 8, which will be y plus 11. And then the only other thing to do is move the 11 to the other side to get the y by itself. So we just need to subtract 11. So we'll get y equals 2 times x plus 2 squared minus 11. And now it's in vertex form, so we can easily pick out our vertex is -2, -11. And our axis of symmetry is the x value of our vertex, but write it as x equals -2. All right, let's look at the last example of putting a quadratic from standard form to vertex form. And I notice I need a y equals on this one, so I'm just going to write it in. Okay, so let's get started. We want to first move the 2 out of the way. Let me grab my blue pen. So -3x squared plus 6x plus blank equals y minus 2 plus blank. And then we want to treat this one the same way we did the last example. We've got to take out the -3 the same way we took out that 2. So let's factor out -3 and then put what's left. So we'll have x squared minus 2x, but still leave plus blank. The blank number is always going to be a positive because of how we figure it out. It will always be positive, because watch what happens. If we take half of b, so b is -2, divided by 2 gives us -1. But then we square that number, so since we square that number, it's always going to be a positive. So then, let me put my blank. Notice we need to have the -3 multiplied by that 1, because you're adding -3 times 1 to the left. You got to add -3 times 1 to the right. So let's bring down what we have now. -3, we made a perfect square trinomial, so we can rewrite it as x minus half of b, which is 1. So x minus 1 squared equals y, and let's clean this side up. So y minus 2 minus 3 gives us y minus 5. And then all we need to do is get y by itself. So that means I need to add that 5 to the other side. So then I get -3, x minus 1 squared plus 5 equals y. And then we can pick out the vertex and the axis of symmetry now that we've done all that good work. So our vertex is 1, 5. Change the sign of parentheses and keep the k the same. And then our axis of symmetry is just x equals 1, since that's the x in our vertex. And that is it.